Welcome back to the Cave of Science, and we're looking at the ChemQuest 31 worksheet using moles with formulas. So I guess let's get right into it. Let's look at the critical thinking question down at the bottom of the first page. And it says for the following questions, use 12 grams per mole of carbon and 1.01 for hydrogen. And I'll be honest with you, for hydrogen, just make it 1. That's pretty much everybody uses 1 for hydrogen. Verify that C4H10, the percent of composition of carbon, is approximately 82 point. Well, we know in this formula, carbon, there are 4 of them. And again, we get that from the subscript, and that has a mass of 12. So that's going to equal 48. We have 10 hydrogen, and that has a mass of 1, so that's going to equal 10, so that's going to equal 58. So we want to find the percent, so it's part over the whole, and we're just looking for carbon. So 48 divided by 58, and that does come out to 82.7%. So again, pretty simple problem, and again, it's part over the whole. All right, let's look on the second page here. Calculate the percent of composition for sodium sulfide on here. Okay, for sodium, and I'll just write it up here. Sodium, we have 2. And the atomic mass, and get that from the periodic table, is 23. So that equals 46. And sulfur, we have 1. And the atomic mass is 32. So that equals 32. And the atomic mass of, or formula mass, if you will, of sodium sulfide is 78. And we want to know the percent of sodium for this. So to find that, we've got sodium is 46, and divide that by 78. And again, percentages, remember you got to multiply by 100, and that comes out to be approximately 60%. So easy enough to do those. So that's pretty good. Let's skip on down to number 3 here. It says verify that the percent of carbon hydrogen for hexene in the table 1 are correct. So again, we got to look at the formula. We have C6H12. So for C, or carbon, we have 6 of those, and it has a atomic mass of 12. So that's going to give us 72. Hydrogen, and again, just use 1 for hydrogen. Hydrogen, we have 12 of those, and it has atomic mass of 1, so that equals 12. So that comes to be 84 grams. So we want to find the percent. So it's part over the whole. So for carbon, it's 72 over 84, and again times 100 because we want percent, and that's about 85.6%, and looks pretty good to what we have up there. And for hydrogen, we'll do the same thing. So it's 12 over 84 times 100, and that equals 14.3%. And they got 14.4. We're pretty good. So not too bad on that one. All right, 4 says fill in the blanks table 1 by determining the percent composition and molecular formulas of each compound. All right, so we're going to shorten this down a little bit here. So first of all, most of the time you're going to especially on these, you're going to name carbon first, hydrogen second. So for carbon we have 1, 2, 3. So that's going to be C3, and let's add up the hydrogens. 1, 2, 3, 4, 5, 6. So H6. Easy enough. This one's C6. 1, 2, 3, 4, 5. This is actually a benzene ring, and hydrogen's 6 also. For this particular cyclobutadiene, 1, 2, 3, 4. So we got 4 carbons, and we also have 4 hydrogens. For 1,5-hexadiene, so again we're going to carbons first. 1, 2, 3, 4, 5, 6. So it's C6, and hydrogen 1, 2, 3, 4, 5, 6. H6. So that was really doing nothing more than adding up the carbons and the hydrogens there. All right. So we want to know the percent. Well, it really works the same as the other one. I'm going to do the first one here. I'll do this one here. I'll do propene. And the rest of these are going to work the same way. So I'm going to do number 4, and let's do propene. C3H6. So I have, for carbon, I've got 3. And again, from the periodic table, you can find it has atomic mass of 12. 3 times 12, if my math is right, is going to be 36. Hydrogen, I have 6. Oops, hydrogen I have, so let's put it here, make it. Hydrogen I have 6, and it has atomic mass of 1. 6 times 1 is 6. So, my mass of the whole thing is going to be 42. And again, typically that's going to be measured in grams. And we want to know the percent of hydrogen and the percent of carbon. Well, it's part over the whole. So on. Now, I guess we can do hydrogen first. So 6 divided by 42 times 100. And again, 6, get my calculator out here. 6 divided by 42 equals times 100. It's going to be about 14%. So for that particular one, it's about 14% of hydrogen. Carbon is 36 divided by 42. So 36 divided by 42 times 100. And if I get my calculator out here, let's clear that. 36 divided by 42, and about 85.7%, or 86% if we want to round it up. And that's going to be 86%. The other 3 work the same way. Same thing as we did really in number 3 and number 4. They are the same. So follow the same procedure. Question number 5. Can you determine a compound's structural formula if you are given the molecular formula? For this class, we are not going to worry about. So we'll do not do. If you're given the molecular formula, yeah, sometimes you can figure it out, but we're not good for our class. We're not going to worry about it. Number 6. What is true about the percent of composition of 2 different compounds that each have the same ratio of carbon to hydrogen? Well, if we look at this one, this is 1 to 1. This one's 1 to 1. And this one is 1 to 1. Same ratio of carbon to hydrogen. Well, you can probably guess if they got the same ratio, they're probably going to have the same percent. So we can leave that there. Number 7, it asks, Can you determine the formula solely from the percent composition? Well, the molecular formula from percent composition, if we start looking at this, you can't determine from the percent composition, you can't determine the molecular formula. These two are pretty close to being the same, and they definitely have a different molecular formula. Typically, you're going to find that they're going to be multiples of one another. So, can you find the molecular formula? Typically, it's not going to happen on there. Again, it could be a multiple looking at those two. So, for this one, we probably would end up saying no. Let's look at number 8. Is it possible to complete the following table? Use only the information in table 1 without the aid of a calculator. So, we got the formula C8H8 and C10H20. This is 1 to 1, and this one is really 1 to 2. I would suggest that this particular stage of the game for what we're doing in this particular class, that the ratios are different here. What you could do if you want to know the percent composition, go back and do what we've been doing, and let's look at C8H8. So carbon, we have 8 of them at 12. Hydrogen, we have 8 of them at 1. And this is going to end up being 96. This is going to be 8, so that's going to give us 104. So we could do, for carbon, 96 divided by 104 times 100. And it's about 7.7%. So we can put that in, well, let's see, 96, I'm sorry, 96 over 104, that's not going to work. That's going to be about 92%, my fault. And 8 divided by 104 is going to be about, it's going to be about 8%. So percent composition of C is going to be 92%. And of hydrogen is going to be about 8%. That's really what we're really in this unit 5, we're really trying to find the percent composition. Alright, so I'm going to end this part here, and then we're going to come back and we'll look at, well, maybe we should finish up 9 and 10 here. We can do that fairly quickly. Well, I'll tell you what. Let's come back and we'll look at that on the next video.